Hi, hello. Today we shall be developing structural equation model, and afterwards we shall try to fit the model. Indeed, there are few criteria for fitting a model, such as uh, LR chi-square, then RMSEA, CFI, TLI, and so on. But we shall try to fit the model as per chi-square criteria. So that means so today we shall be fitting our model according to chi-square criteria, LR chi-square criteria. Excuse me. And here we have few unobserved variables, such as number one, depression, number two, family environment, and number three, economic situation. And these variables also known as a latent variable, because these variables are not observed, they are unobserved. But the question is that how to measure these three variables: number one, number two, number three. Okay, and there are some indicators. There are some indicators that can measure those variables, right? Okay. And here actually here what I have done, I have asked 400 depression patient, and I have asked them following questions. Okay. So actually, so the whole thing is a depression patient model. So the first variable is depression, and this is unobserved variable. And here my first question was to a patient: number one, do you feel sad all the time? And that is A1. Number two, do you feel to harm yourself? That is A2. And number three, do you feel hopeless? That is A3. So here A1, A2, A3, A1, A2, and A3 are the indicators to estimate depression, right? Right? And A1, A2, A3, these three variables are observed variables, meaning that they have the data. But this variable, which is called depression, has no real data. And this variable, which is depression can be measured by these three variables. those are A1, A2, A3. Okay, and here we have also second variable, that is family environment, and these are the question to a patient, to all the patient. Do you feel someone in the family is active against your interest? That is B1. Number 2, family income is not enough to support your livelihood. That is B2. And number 3, domestic violence is affecting you. That is B3. So here B1, B2 and B3 are the indicator to estimate family environment. And the third variable is economic situation. And here there are two questions. Economy is going down very fast. That is C1. And number 2, likely to lose job very soon. That is C2. And here are 5 criteria. Strongly agree means 1, agree means 2, neutral means 3, disagree means 4, and strongly disagree means 5. And the patient will answer accordingly. The patients will answer as per above, such as either 1 or 2 or 3 or 4 or 5. The patient can choose, right, after asking all these questions. Okay, so we are set now, and I can show my model to you. That I can show you my model. The model actually I have already done, and the model is here. You can see the model. So you can see I make it big so that you can see better. Okay, I can make it further big if you want, right? Is it so? Okay, is it fine? Okay, you can see the first variable which is unobserved, that is depression, and she has 3 indicators, A1, A2, A3. And the second latent variable is an environment, and she has also three observed variable to measure, and those are B1, B2, B3. And the third latent variable is economic, and she has 2 variable to measure, such as C1 and C2. And our data, you can see our data is like this. Our data that I show you, not this one, I'm sorry. Our data is here. Our data is these are our data. So actually the data is A1, A2, A3, B1, B2 and B3, C1, C2, and so these are our data, right? And you can see all the data are from 1 to 5, right? You can see start from here, number 1, 1 to 5. You can see all the data are here. It's going down, and there are 400 patients. I told you there are 400 patients and their answers are here, right? Their answers are here. Okay. Okay. Now I shall estimate the model and try to feed the model. So that is our main job actually, right? Okay. So what I do, I estimate my model. That is my first job. Sorry, here. Okay. Okay. So what I do, I go to setting, sorry, estimate, and I choose estimate. Okay. Okay, and this will come here, and then I choose OK to estimate the model, and you can see. So that, okay, so you can see, and actually this one actually unstandardized estimate, right? Unstandardized estimates, right? Estimates. Okay, and our target is to feed the model as per LR chi-square criteria. LR chi-square criteria. That is our target to feed the model today. Okay. And here you can see structural equation model, and you can see our variables are here, things are here, right? So actually this one is the dependent variable and this one is the independent variable. Coefficient, standard error, z statistics, probability value, all are here, right? Okay, and this is the variance, right, of all, and this is the covariance between two variables, right? And finally, actually we are here, LR test of chi-square. The value of chi-square is 46.46, but the probability is less than 5%. So actually what is happening here, I can show you. The chi-square value is how much? 46.46, and the probability value is 0.0001, right? So it means that it is actually 0.001%, right? It means that, sorry, I've done a mistake. It means that 0.01%. So actually this value is very small, 0.01%. So meaning that this criteria is significant, and when the LR chi-square criteria is significant, meaning that model is not fitted. Model is not fitted. So to be fitted, the model, the chi-square value should not be significant. meaning that p-value should be more than 5%. P-value should be more than 5%, right? Okay. And here the problem is that probability value is less than 5%. So the model is not fitted. So we are not happy about this model. And our target actually to make the model fitted. That we want to do. And one more thing, there is an inverse relationship between chi-square value and p-value all the time, right? So one important thing there is an inverse associationship between chi-square value and p-value all the time. So actually what happens, so this one is the chi-square value and this one is the p-value. So normally what happens, when this chi-square value goes up, then probability value goes down, or if this chi-square value goes down, then probability value goes up. That always happens. So we have to make the chi-square value low so that p-value can go up and become non-significant. And that is our desirable, and that is our target. So what is our target? How to reduce the chi-square value. That means these value. So as a result, p-value will go up and the value will become non-significant. Then our model will be fitted. Okay, to do it we go to modification indices, right? Okay, I go to statistics. Sorry, not statistics, sorry, I have done a mistake. I go to my model, right? I go to estimation, testing CI, then modification indices. I select this one, and modification in indices here. So then I select OK. Okay. So so you can see the result of modification indices, right? You can see from here result. Okay, and this is mi, modification indices, degree of freedom, this is the probability, right? These are here. Okay, and here actually what is mi? Modification indices, meaning that how much chi-square value will go down. So that is called modification indices, right? Okay, suppose so A1 is the dependent variable and environment is the independent variable, and if I connect this A1 with an environment, then chi-square value will go down by 10.520. As a result, p value will go up. Okay, and there is also we have some more options. Suppose example this one, if I connect depression with b1, then the chi-square value will go down by 18.024. And so this one you can choose this one, you can choose this one, you can choose this one, so you can choose many options, but normally I choose which one will lower the chi-square most, that I shall choose. And here you can see the highest chi-square value will go down is this one, 18.385. But we have to connect between the EB2 versus EB3. We have to connect, co-vary between EB2 versus EB3. Okay, here what is E? E actually error term. Okay, we talk about what does mean by EB2. It means that error term with B2 indicator, right? That we have. Okay. So this one is the highest. So we better connect between EB2 versus EB3, right? That means covariance between EB2 and EB3, right? As a result, the chi-square value will go down about 18.385. Okay, meaning that chi-square value actually last time the chi-square value was 46.46, and this value will go down about 18.385, provided we connect these two variables, and that we shall do now. EB2, EB3, right? Okay, I see the models. Here you can see this one is the EB2, right? E, and this one is the EB3, right? So we better make a covariance, right? We better connect as a covariance like this. Okay, so it has been connected now. Okay, it has been connected. Okay, now after connecting, we estimate the model again, right? And see what happens. So we estimate again. Press OK. So what is happening here? Okay, so this one is our new outcome. You can see from here. You can see new outcome are here, right? You can see covariance between EB2, EB3, right? And as a result, what happened? The chi-square value has become 25.41 and probability value has gone up, right? And it has become non-significant, right? So the chi-square value become 25.41. How? Okay, so actually I'm telling from the beginning. Okay, so the first value of chi-square was how much? 46. The chi-square value was how much? The first one, chi-square value was 46.46, and minus, I take it minus how much? How much? Minus 18.385, right? After connecting EB to EB3, minus 18.385. So as a result, the value would be, okay, actually I can take it like this: 47 minus I take it as 18, right? Make it okay. So the figure would be around how much? So actually this 46.46, okay, I take it 46, okay, and 18.385 I take it as 18. So 46 minus 18, the figure would be, should be 8, and should be 8 and 2, 28, right? The chi-square value should be about 28, right? And we see how much it has been. We check how much it has been. Okay, it has been actually 25.41, and 25.41 is very close to 28, right? So we are happy about the model, and we are happy because the probability value has become 6.29%. That means, which is more than 5%, meaning that it is non-significant, meaning that model is fitted. So we are happy about the model. Okay, now we can also further lower the value of chi-square to make the value of p further up. We can also do it, right? Okay, then we check again modification in indices, right? Mi, right? Okay, So what I do, I go to again and I check again modification in indices again, and this one is this one. I press OK. So again, right? So this is the MI, and here you can see if I connect environment as a independent variable and A1 as a dependent variable, then chi-square value will go down by 8.004, and if I connect EA1 and EC2, so the value will go down by 4.066 and so on, right? But normally we choose the highest one, that is 8.004, right? But here we have to connect environment with A1 and make sure A1 should be the dependent variable and environment should be independent variable. But make sure we are going to connect this and this, but make sure it must be according to economic theory. We simply cannot connect. There must have economic theory behind this two connection, right? We simply cannot add, right? There must have a strong reason behind it. That means economic reason or economic theory or so on. Okay. Suppose I assume that environment 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 and A1, these two variables has strong association. Suppose I assume they follow the economic theory, right? Okay, then now I can connect, right? Okay, that means here is the B1, right? I just double check. Sorry, environment versus A1, right? So meaning that I just go to my model, and this is environment and this is A1. So this time I take this one, right? Right, this one straight line. Okay, so as a result, because this one become independent variable and this one has become dependent variable according to the advice by MI, right? And that we have done here, and I assume that there is a strong background behind it. And also when I connect these two, that means between EB2 and EB3, there must have also a strong reason behind it. If there is no strong reason, we simply cannot connect these two. Make sure we simply cannot connect. But I also assume that there is a strong reason behind connecting these two residual. Okay. Now we are ready. Now we can run the model again after connecting this and this. Okay, then I estimate it. Okay, and I check the result. Where is the result? It's come up here. Yes. So you can see, so the result is coming here. Okay, so the last time, just I show you, last time, okay, last time the chi-square value was 25.41 and p value was okay, I just write it, chi-square last time was how much, 25.41, and p value was 0.0629, right, meaning that 6.29%, right, 6.29%. Okay, 6.29%. Okay, now actually this chi-square value will go down by how much? This chi-square value will go down by how much? It should go down by 8.04 after connecting A1 and environment. So meaning that, so the chi-square value should be around how much? Should be around 20 or less than 20, something like that, right? Close to 20, right? Right? So we check that what has happened actually. We check what has happened actually after connecting it. Yes, chi-square value has become 16.58, meaning that 17, which is close to 20, right, which is close to 20, and you can see probability value has gone up 34.46%. That means the highly fitted, the model is highly fitted, right, the model is highly fitted. So I think we have done enough because our model is already fitted, so we have no other complaint. And also you can see we connected this one and it has become significant, right, and also we connected this variable, that is environment versus A1, and that one has also become significant according to the advice of MI. So we are happy about the model, right? We are happy about the model because both are significant, right? Okay, so I think so that is the way to make a model non-significant using MI using modification indices. Modification indices. Okay, thank you very much for being with me.